What's up? In this video, I wanted to talk about a slightly more positive topic because my last video was talking about the apocalyptic conditions of the mathematical literacy in this country. But I want to switch topics and I want to talk about something positive and something that I'm very passionate about. I want to talk about the beauty of mathematics and also the tragic aspect that many people will not be able to enjoy that beauty. I see there's a sort of dualism in the beauty inherent within math and how fleeting that beauty is and how difficult it is for many people to appreciate it or even know that it's out there in the first place. Before I go further, I want to make you guys aware that I've made a Discord. I've had the privilege of talking with some of you guys on several occasions in the comments. I see some people that comment from time to time on a recurring basis. If you guys are interested, I think this would be a great chance for us to sort of build a sort of community and to talk about things related to math and machine learning in a more persistent area than just a YouTube comment section. If that interests you, I'm going to leave the link in the description. Now, before I move on and talk about the main thing that I want to discuss in this video, which is the beauty of math and the tragic aspect of how it evades many people, I would like to read a quote by Yukio Mishima from his book Sun and Steel, which reminds me very much about the feelings that are evoked in me when I think about math and my relationship with learning math. So I'm just going to read it verbatim because I don't want to paraphrase it and get it wrong. So it goes like this. It is not surprising that an anathema for words should draw one's attention to the essentially dubious nature of the act of expression. Why do we conceive the desire to give expression to things that cannot be said and sometimes succeed? Such success is a phenomenon that occurs when a subtle arrangement of words excites the reader's imagination to an extreme degree. At that moment, author and reader become accomplices in a crime of the imagination. In this quote, Mishima is talking about how you can capture seemingly ineffable ideas and subjects with words, and in so doing, the author and the reader have sort of committed this crime of the imagination where they have taken something that seems impossible to understand and elucidate with words and given it a concrete structure that they share together. And although they're talking about, in this quote, they're talking about words and writing, I feel a very similar sense in math. Oftentimes you're able to take a very difficult and complex subject and you're able to formalize it in a very beautiful way, and you're able to prove properties about it. You're able to make these very simple and elegant proofs that have such deep implications and results. And in that sense, I feel like the mathematician and whoever it is that is reading his or her work, there's a similar relationship between them and their students and the author and the reader that Mishima is talking about, where it's almost as though they've become accomplices in describing something and in giving something form that feels as though it should be formless, it should be ineffable, it should be impossible to capture and pin down and describe concretely, but yet it is. And that's the feeling that I feel evoked in myself when I learn math and when I understand how math is able to describe such complicated things about our universe and about its own structure in really very simple and elegant and beautiful ways. So let me give a couple of examples of things that I find to be beautiful about math, or in my experience, I found to be particularly beautiful, or I suppose transformational might not be the right word, but which happened to have a particular importance to me at the time that they were taught to me. So the first thing is that I didn't have a profound passion or interest in math in high school. I didn't take any higher level math classes. I took Calculus 1, but I didn't take AP, any of that. I just took regular math classes for the most part. So I didn't have any sort of special passion for the subject. And going into college, I actually was not doing a math major. I was doing a computer science major. But I found that although computer science is interesting, I certainly didn't have a passion for it that many of my peers did. And so I kind of made the resolution of, maybe I should do something else because I'm seeing kids that are working on their projects outside of class. They've been coding since middle school. Meanwhile, I'm still trying to learn how to print stuff in Java. And the moment to make the decision to learn something else and pursue something else was given to me when I was taking my Calculus 2 class. And at the end of that Calculus 2 class, we were learning about infinite series. We were learning about, the properties and convergence of infinite series. And as we got to alternating series, our teacher showed us the Riemann rearrangement theorem, which is a result about divergent alternating series. And it was fascinating to me that you could take a series with that structure and manipulate it such that it was able to approach any sort of value, and that if we treated it as though it did converge, it would be able to converge to pretty much any number. That was insane to me. I think the example that he showed us was that you could have a series, and by applying the Riemann arrangement theorem or rearrangement theorem, you could manipulate it so that it converged to anything. It can converge to pi, it can converge to natural log of 2, whatever. And that blew my mind because I really had a very surface level understanding of infinite series, and a result like that seemed honestly to be impossible. And so that sparked a profound interest in me, and it was really at that moment that I decided I was going to change my major and I was going to learn math. I actually swapped to regular math first, and then I swapped to applied math. So what followed is that I started to take these foundational courses that transcended just the surface level of math and got into some of the foundational topics, and really tried to drive at the center of where does this come from? How do we formalize it? What is at the core of math? And so I took proof-based courses, I took analysis, and in analysis you actually, at least in my class, we talked about the Riemann rearrangement theorem, and I had this epiphany of looking at that result from two different views. The first view of a student who just understands it tangentially as something that's provided to you when you're learning about infinite series, and then a second, much more deep and rich understanding that was supported by the rigors of mathematical analysis, where we formalize everything, we take nothing for granted, and you have to prove everything beyond a shadow of a doubt. It was really around that point that I was able to appreciate the beauty of math, that we could take things that seem so beyond humans, so difficult to reach, something like infinity or a sum of infinitely many things, and we're able to talk about what happens. We're able to talk about what's the behavior that we see out at infinity. It seems like, we shouldn't be able to interact with infinity at all, but the fact that we can, it feels like what Mishima is talking about, where the reader and the author become accomplices in something. That's what it felt like to me when I was learning math, and I was learning about all of these things that felt like, it felt kind of spooky the first time I was introduced to it, of being able to interact with and manipulate infinity. Another example I think of just off the top of my head is Cantor's diagonalization theorem, because you talk about infinity and you talk to a person who's not from a mathematical background, you tell them there are different sizes of infinity, and they look at you like you're crazy, because what could that mean? Infinity already isn't something you can wrap your head around. What do you mean there are different sizes of it? But then you write out the diagonalization proof, and it's extremely simple. I think really most people can understand it without needing a very technical background in math. And that's the beauty that I see in it, is that so many of these profound results, which strike awe in me and strike awe in a lot of people, can be communicated in a very easy way to people that don't necessarily need to have years of technical background in the subject. That's, it feels as though math as a science is, it's like the meta science, so to speak. It's one of the most pure sciences, because it takes nothing for granted, and it proceeds from only the minimal assumptions and foundations, and then from there it constructs everything and it discovers everything, and there are these logical implications that all harken back to these first, most basic assumptions that we make. And no matter how advanced your result is, no matter how far it feels like it is from the fundamentals, no matter how detached it feels, you can trace the logical implications, if you so choose, all the way back to the very beginning. And that's what's so beautiful about it, is that it's so abstracted away, and the math that you work with might be so many degrees of separation from the foundational math and set theory, but nevertheless it's true. And oftentimes we can use those abstractions to present very difficult and complex ideas in very simple and elegant ways, in ways that make it easy to understand for people that might not have that rigorous background in set theory and analysis and things like that. But unfortunately, and this is the tragic aspect that I'm talking about, most people are not going to have the privilege of appreciating the beauty of math and understanding what there really is out there. For a lot of people, their life, they've had a negative connotation with math, and that really ended for a lot of people in high school. It ended with algebra or pre-calculus or maybe calculus, and then they didn't take it any further. And I think the way that we teach math in sort of like the industrialized public education system does a great disservice to the subject. They really brutalize the subject in that the way it's presented is that you memorize formulas, you do rote computations, and very rarely, if ever, is there any effort put forth to explain where things come from, why they work the way they do, and the techniques of the subject. You know, it seems like results just sort of spawn out of thin air. And for a lot of people, that's why they come to hate math, is that it feels like some big game where you don't know the rules and things just sort of are the way they are because you're told that they are. And for a lot of people, that becomes demoralizing, because that makes learning math difficult, and it turns them off from ever wanting to get to the bottom of things and see, you know, why is this the way that it is? Why do we have objects and properties that behave a certain way? I truly believe that if it's communicated in the right way, and the person communicating it is earnest, and the reader or the student is earnest, that everybody would be able to find beauty and appreciate math, because math gives us a way to formalize the universe in a way that really feels to me as though it should not be possible. Going back to the quote of Mishima, it really seems bizarre to me, absurd even, that we can take something as complicated as our universe and use math to describe it in ways that are, for the most part, deterministic. You can understand how the world is going to behave more or less by applying mathematical models and enforcing them on the world around you. And, you know, it's not perfect. There are certain holes that we have still yet to fill in, but it works absurdly well, and it works really more well than I feel like it should. But for most people, math ends with algebra. It ends with the quadratic formula or the Pythagorean theorem, or it ends with confusion and dismay over the beginnings of calculus. And they'll never be able to reach the appreciation and the euphoria that I've been privileged to reach, for one reason or another, because either that opportunity was never afforded to them, or their relationship with math was sort of destroyed in one of the most formative moments of it, when it otherwise could have been turned into a passion for them. But if you're someone like me and you're coming from a place where you've studied math and you've come to appreciate its depth and its importance, you might not want to use such flowery philosophical language, but there is a beauty in it. I feel like you don't have to have any sort of religious convictions or any sort of philosophical convictions to say objectively that there's a beauty in our ability to assign order to chaos and to describe the structure of things in a way that shouldn't be possible or feels as though it's impossible through the mechanisms of mathematics. And it's something that I have just such a deep appreciation for, I have such a deep interest in, and it's something that I'm going to carry with me for the rest of my life, no matter what it is I end up doing. And I just wish more people would have the chance to have this experience, to have the euphoria of finally understanding something after, a lot of time of arduous and assiduous study, being able to say, I understand how this works at the deepest level from top to bottom. It's such a great feeling. But yeah, this is more of just like a philosophical rambling video, but I wanted to talk about something more positive, even though there is that tragic aspect in the dualism between the beauty and the tragedy. I do think that the overall message I'm trying to convey is that there's immense beauty in mathematics, and that if you're one of the few people that is privileged enough to come into contact with it in your life that you really need to treasure it, because most people are unaware of what there is out there in math and what math could offer them. And I think it's a shame that many people are not going to be able to appreciate it on the level that we are. But I hope this channel serves as an infinitesimal contribution in the direction of having more people appreciate math and explore math and have a desire to understand it, even if it's just a little bit more than they currently do. But that brings me to the end of my thoughts. I would like to say, if you guys want help in math, I offer tutoring for high school level ACT and SAT prep and university level math. If you want help, let's do a free consultation. Go to my website. It's www.kuehrtutoring.com. That's KUEHR tutoring.com. Book a free consultation with me. We'll figure out where you're at, how I can meet you there, and how I can help you out. But other than that, guys, that's the end of this video. Have a good one. Thank you for watching.